second in the series of plate making webinars. This is the Platemaking Advanced session, and today we have 4 presenters, 3 from Esko, myself, Robert Bruce, Jan Bukvijts and Ashish Mishra, and from our friends at DuPont, we have Piero, who's going to be talking about the plate side of things. We've got a packed agenda for you today, so without further ado, what we'll start with is the software side, then we'll move into our CDI IoT, then the XPS itself, and the plates that sit around this technology. So first of all, software, and we'll start with the calibration and screening process for the XPS. So this is using a product called Print Control Wizard, and the aim of this particular product is to try and simplify the fingerprint process, deliver these crystal screens with the correct calibration, and also offer a ICC color profile. We do that in a slightly different way to the traditional format of fingerprinting that you can see on the top here, which generally means 3 different trips to the printing press, creating various test forms, manually keying, dot gain curves, etc. With the Print Control Wizard, we use a pre-built test chart and an I1IO to create this data set very, very quickly, and which can then be automatically input into your RIP ticket. So that's the first part. The second part is the crystal screens that we look to generate. And for the crystal screens, we focus on 4 components that's illustrated here. The minimum dot, which obviously needs to be very, very stable. The transition, going from a stochastic highlight into an AM grid in the smoothest possible way. Then we offer various different dot shapes in the midtones to try and ensure that you can print as cleanly as possible. And then in the shadows and in the solids, we're looking to try and achieve a good ink coverage, pinhole free. So how do we do that? So we have within these 4 different components, first of all, number 1, highlight options. So with the various different plates that are on the market, we need to offer different minimum dot options. And we do that by controlling the dot size. So that's the number of pixels in the dot. And then what we call the dot distance. So how far are these spread apart? And these are variables then which are really dependent on your plate making process and also your printing environment. The second is the transition. So we use a 2-factor dot shape, a small dot and a large dot to smooth that transition. The third stage is the dot shape. We can choose various different dot shapes, typically using a circular dot as it's easier to control the curves. And then again, we have different options for the surface patterns. So we provide all these different options to allow you to use these different printing conditions on your press and tune your plates to your printing condition. A little bit more detail. So here you can see some developments that we've done in comparison between historical technology, Crystal C, moving to Crystal V. On the left-hand side, you can see the Crystal C, which is using an algorithm called dot deletion. And from that, you can see a little bit of noise that's created. And what we've done with the Crystal V is remove that noise and place the dots in a much easier way for the eye to absorb the reflection, the light. And you can see the difference here in the print. In the midtones, sorry, in the transition between AM to FM, historically we use this 1-dimensional transition. So we would choose a minimum dot size. In this instance, it's 9 pixels, and then we would just look to fade that out to 0 as much as possible. What you can see here is that creates a slightly noisy zone in between the AM and FM. What we do now is we have a 2-dimensional transition using a small dot and a large dot, and this enables us to push the transition further down the vignette, and that's illustrated here with this particular configuration, 133 lines per inch with a 36 pixel minimum dot. And what we've done with the Crystal V is we've placed a 16 pixel dot in between, and you can see the difference there on the print on the left. The Crystal C has this dot deletion and some noise, and on the right you can see that it looks nice and smooth on the grid. The right hand side is the bitmap data, where again you can see that there's on the bottom in the green circle, you can see the small and the large dots, and on top of that you can just see the dot deletion. So it looks much smoother transition now. In the midtones, for flexible packaging and printing on film, we would typically use a crystal dot that you can see on the right. And this really does improve the way that the ink flows from the plate to the substrate, making it much easier to print with these plates. And here you can see a CMYK illustration where we would typically see a standard screen dot versus the crystal screens. A little bit of an explanation as to the definition, what we call them. We have lots of different types of crystal screens, whether you're printing on paper, film, UV ink, solvent inks, and we have all these different combinations that could be seen. So this is just a quick definition overview. It's not just CMYK or CMYK orange, green, violet, or an extended gamut set that we're looking to focus on with crystal screens. We're also looking at whites and Pantone colors. And here we have a test chart that you can just use, print on your white deck with your standard analogs configuration, or with Pantone colors, and then figure out which pattern works best for you. And again, what we're looking to try and achieve here, number 4 on the grid on the previous slide, is we're looking to try and improve that ink lay down to make it as smooth as possible. So that's our calibration screens and curves in a very quick overview. Now I'm going to look to move on to, once we have that bitmap data, the len files in place, how do we then prepare that file for plate making? And for this, we have a product called Flexo Engine, and the concept here is we're looking to digitize and automate, simplify the file preparation for flexo plate making. And we do that in a few steps. So here you can see a typical ecosystem or a flow of how a file would go to a CDI, and the various tasks that are undertaken. And the ones in pink are the ones that we're looking to work on with Flexo Engine. First one is generating the plate cut path for the cutting table. And historically, we've used a number of manual tools to create this staggered cut path: Plato, Art Pro, Digital Flexo Suite, Art Pro Plus. And now with Flexo Engine, we can look to automate that task just as a ticket. So within this ticket, you see all the standard parameters that you would need to set up a cut path. And now we automate this process in the background. If we're using Art Pro Plus, then the Art Pro Plus file has all the metadata required for the ticket to understand the plate circumference. If the PDF is coming from an external source, Illustrator for instance, then we would need to add the information into this plate circumference section of the ticket. And that can be done in various ways. It can be done manually, or it could be smart marked, pulled in from your MIS system, for instance. Second part is plate ID or plate identification. So there are a number of different ways that people are looking to help the plate mounter understand what plate he's looking to mount. Typical information that goes on these plates is order number, color, maybe some sort of job reference. People today would typically use a cutting table to scribe this information onto the plate, or maybe even just handwrite it with a Sharpie. But this is, but both functions are time consuming, and of course, if you're using solvent-based inks, then when you come to clean the plate, then this information just gets wiped off. So when you come to reuse the plate or reprint with the plate, this information is gone and disappeared. So Our solution, again, with the added control that we have now with the XPS, is Plate ID, and this is part of a workflow. Basically, what we're doing, if you look at the top left-hand corner, in grey, you can see the standard printing height of a plate, and what we're looking to do is build in an intermediate layer in green as part of the plate making process, so it doesn't take any extra time to produce this. And this data then becomes readable and permanent on the plate. We do this as part of, like I say, a software flow. We can pull all the information in from your MIS system through automation engine, the Flexo engine module, where we can look to pick out the type of information that you want to add, and then it gets pulled through to the CDI. We have a standard operating procedure of how to do this. All the requirements are set up, implementation, and so forth. It's quite a straightforward process to implement. Next is plate merging. And the first part is typically this would be a manual step to go and look for files, drag them into the merger, and then look to compile it, probably based on paper orders. We can now look to do this in a much simplified way using Flexo engine, where we can either fully automate this process based on a fill rate. So basically, you just tell the software what the fill rate of the plate should be. So if you've got maybe 20% plate waste and you're looking to reduce that down to 18, you would put a fill rate of 82%, and then we would keep adding files and remerging until we can hit that fill rate, and then the file gets automatically sent to the CDI and the cut path to the Kongsberg table. Also within the merger is the solvent saver feature. So again, looking at the average plate waste being 20%, you would generally waste 20% of your solvent. And what we do with this particular feature is where you see the squares on the top and the right-hand side, this would typically just be left empty, and you would use solvent to process these areas. What we do is we automatically, before we send the file to the CDI, we scan these areas, and then we apply this layer over the top, which is then ablated on the CDI. With the way that this particular image is set up, it wouldn't add any extra time to the plate imaging. Why would you look to use this type of feature, solvent saver? Well, there's various cost and quality benefits that can be explored here, which are quite pertinent, especially things like cost as consumables continue to rise. We also have a nested merging feature now as part of Flexo engine. So historically, we would merge based on the bounding box of the len file. And now what we can do is we can merge based on the cut profile. So what you see here on this particular Flexo engine illustration is a bunch of len files that we've been able to nest. And we've been able to create some additional space on the plate. And we have a feature now where we can load more plates. These load more plates are based on the actual plate type itself. So when we look to merge, we'll base it on the plate type. So if it's 1.14 LSH plate, then all you would see is the files for 1.14 LSH. And so it's almost impossible to select the wrong file for the wrong plate type. And you just drag and drop them across onto the canvas that you see here. So again, in terms of those rising consumable costs, it's a nice way to try and reduce waste. Final feature is the dashboarding and reporting. So again, inside of Automation Engine, on the left-hand side, we have track and trace functionality for the CDI and the Kongsberg table. We have this direct link to the CDI, so you don't need to be in the plate making department to understand which job is being produced next. You can view and see that. You can also, from the pilot, change the sequence of the jobs that's going to be produced on the CDI. And because we have all this information in the automation engine database, we can export that and create customized reports. Just a quick heads up, we in terms of consumable costs, we launched a campaign back in November to try and illustrate and understand how we can look to save waste using this calculator that's on our website. And it was quite interesting that quite a few companies responded, and you can see the type of savings that was based on these 24 customers. So by using this software, we can look to maximize quality, but we're also looking to try and reduce costs whenever possible. And that ends my part of the webinar, and I'll hand it over now to Ashish to talk quickly about IoT.
Thank you. All right, so I'll quickly share our concept of the IoT. Just so that, am I audible?
Yes.
Perfect. Right, so how do we see IoT helping the flexible packaging is to uncover the value from the device data. So the Flexo IoT is a solution which will help centralize information in a secure cloud environment, which means that the plate and the job link information can be transferred across sites. It allows, and also especially for backup and restoration, it allows this backup of a device settings in the cloud. So let's say you have to move a device from one place to the other, or there are any plate link settings, you can actually download it from the cloud if you have lost it. Second one is the reduced downtime. So Flexo IoT actually helps Esko be more proactive in providing service. It helps us quicker troubleshooting by rightly pointing out which area of the device actually has an issue. More importantly, it also allows us to look into the device performance insights over time, right? So if we see that some of a part actually has shown degradation, we can come and fix it before anything breaks, right? So it allows you to have your operations not have any interruptions. It allows remote monitoring, as we had seen during the COVID, right? That it is important that we have some form of visibility in what is actually happening on the shop floor. This tool actually allows what exactly is happening at each of your location and on each of your images and XPSs. It allows to increase consistency by improving the plate wastage patterns, and more importantly, it allows to compare output across sites and other peers. The peer group is created by collecting anonymized data on performance and the output on a similar sized device. So the biggest impact from this tool is that it allows you to have insights on the usage of your CDIs, right? So it shows, okay, what exactly is your imaging output from across your different sites, and it can actually provide information on trends. So for example, if your production actually this month has gone down by 10% less than last month, you can quickly figure out, is it because of the job queue, or are there any errors which due to training of the operators, which is constantly recurring, right? So you can actually find out those problems and try to solve them. So from a user's perspective, we see this IoT dashboard actually being useful for the operators, the production managers, as well as the administrators. And here is an example. So this is actually coming from a live data on one of our CDIs at Esko. You can actually start seeing that, a historical trend of how much the CDI has been imaging. It by default it shows a 30-day view, but you can actually go as far as back in the history. It also shows you the output of the number of jobs. And because it actually has a live connection, it actually shows if there is, let's say, an outage at a particular site or at a particular CDI. So for example, it shows that no data is pushed in the past 8 hours. More importantly, you can actually start looking remotely in which jobs are actually being processed on each day, right? How does your shift timing looks like, and which jobs actually take longer, and maybe due to the user or operator, being busy at other places. And in a way, it helps you reorganize your shift and production so that you can constantly image more plates in a day. From a systems perspective, we also keep track of the laser temperature, right? So as you can, the blue line actually shows the average temperature, right? So it means that the power which is being supplied to the laser on the CDI isn't dropping off, which means everything is okay. But if we actually started seeing the trend going down, it means that we should actually look at a possible intervention. Job errors. So it also provides a UI at a central level to look into what are the different jobs which have been performed on your CDIs and what exactly the error has happened on a CDI. And it gives you an overview of the locations. So for example, if you have, let's say, 5 locations on which your CDIs are scattered around, you can build a map of each locations on the CDIs and do a comparison across different locations. So as I repeated earlier as well, right? Like it allows you to do comparisons across sites, across peer group as well. The data which is shown here is actually anonymized, right? So you can actually compare how much the plate consumption is in a day for your CDI versus, let's say, another CDI in your region, which has got a similar format. It also gives you interesting insights around the plate thickness variations. So for example, if you want to optimize your plate consumptions across different sites and move jobs around, it allows you to do so. Okay, so I'll stop sharing now and hand it over to Jan.
Yes, thank you. Share the screen. Yeah. All right, let's talk about the XPS Crystal now. Let me see. A second. As shown in the first part, the basic part, we already talked about. That's in the end, it's the complete line of things we are doing. As Robert explained and Ashish explained, it's all about having a smooth workflow from the beginning, from the file creation to, in the end, the printing machine. What I will talk about today is I will talk about the XPS Crystal and the benefits of it. XPS Crystal, of course, was built when we defined it. So you know maybe that we started with inline UV, which was just a moving head or a fixed head inside of the CDI. The XPS Crystal is currently changing the game in Flexo completely because it does the back and main exposure at the same time. It gives highest consistency. It is increased the quality dramatically of the plates, but also the tolerance and the robustness of the plates. The XPS Crystal is built to be integrated and fully automated in the complete flow. And last but not least, simplicity, ease of use is key for all devices we are building. So what is the XPS Crystal? As said, we have a one back exposure head here in the upper right corner. You see that we simultaneously do back and main exposure. Yeah, we scan the surface of the plate depending on the behavior of the plates or the requirements of the plates. Plates can only swallow a specific amount of UV light per time. This need to be respected. That's why per plate type we go different paths. Yeah, all these parameters are inside of the system. So nothing to select, to try out, and so on. And last but not least, here you see the touch screen. The only thing you do is you go for the predefined plate formats, plate types and plate thicknesses, and then you just hit the button to start the system. Unmatched consistency and quality it is because of the fact that we emit the light via UV LEDs, that we homogenize the light inside of a kaleidoscope, so a mirroring system, and we distribute it to the surface of the plate. This ensures that every square centimeter gets the same amount of light, so that the cross-linking is totally homogeneous. When it comes to an effect you today might see is, whenever you do today on a bank light table, you do your bag exposure, maybe 5 plates in the morning, you bag expose, and then over the day you image the plate and do the main exposure. You will see that your dots are shrinking because the connection of the dots is releasing over time. Recommendation is stick to a fixed window, always bag exposure, always imaging, always main exposure, and that sequence for bank light tables. On the XPS Crystal, it doesn't matter. You image first, and then you do the bag and main exposure in one go. Always you have a trusted result. Here you see what it means if you have time between. So let's say between bag and main exposure, you have 1 hour. Yeah. This means that the dots get lost. This is what you want to have. Yeah, it can be very dramatic. It is less dramatic with flat top dot plates, but there is a loss in details. So the benefits in detail, we have more than 450 devices installed. We have a list of predefined parameters, so more than 300 plate types and plate thicknesses are in that list. You do not have to teach in any parameters. We even go for partial plate modes for 50 in XPS Crystal 5080. You can also expose the times quicker. As you can see here, the exposure times for an LSH plate. It's 15 minutes for a 5080 plate, 11 or nearly 12 minutes for a 4260 plate, and 8 minutes about for a 4835 format. So meaning if you only go for a half plate, just select the 4835 format and only half of the surface is scanned. Important, if you want to match the desired plate relief the printer wants from you, just type it in and you get exactly that relief you are asking for. That's the only parameter where we give full access because this is required by the printers. We even come with speed parameters. If you say you don't want to go for the highest quality which we offer, but you say, I'm in corrugated, I'm good with 80% of the quality, but I want more productivity, we can increase the throughput by up to 40%. Yeah. And last but not least, you can go for your own parameters. We have test plates, we have custom plates in that system where you can define your own parameters, but be aware of you need to go for fingerprints to double check the result as you do today. This solution is available for the XPS crystals from day one once we introduced it. So if you want to do your own plate parameters, just do it. Talking about the benefits, we try to put numbers behind that. So feedback from customers, you see here that I'm addressing 6 points here, starting with energy savings. Energy savings, we received the certification from XPS for the XPS Crystal by Green Circle. So the dematerialization had been checked, the energy savings had been checked, how much energy we are saving, but also how much material can be saved. Here you see the 2 main points. It is about saving kilowatts, but it's also getting rid of the mercury inside of this, which are in the bulbs. Coming to, especially for Europe, I'm not, I believe that in other areas of the world there are any similar initiatives, but the EU directive 2011/65 EU says that bulbs will be banned in the future. This is because of the higher energy consumption, but it's mainly because of the mercury the bulbs contain. So sustainability is a hot topic. Just check about that, and think about switching to a solution which gives you which is totally free of mercury. Here, it's just a comparison when it comes to dematerialization. Over 5,000 hours. Actually, the UV heads of the XPS Crystal last a lot longer, as we learned. So we have inland UV heads up to 20,000 hours running. So, but let's take this figure of 5,000 hours to make the comparison easy. If we say after 5,000 hours, we would have to replace the UV diodes, which actually is not. At the same time, you have to exchange about 580 UV bulbs. Here we took the number of 450 hours per bulb. It can differ. If you say you're good with longer times, okay, it can change, but you see that just calculating these numbers here and taking into account that 50 milligrams of toxic mercury are inside of one bulb, then you see the result of it when the bulbs are not disposed properly. Just think about that. And there are areas where the disposal is not really good enough, but you see how much drinking water could be poisoned. We are talking about 130 million liters of water. I believe that all of you do a good job in disposing these bulbs, so that's why it should not be a problem. Getting rid of mercury, but anyway, is a good way. Pure plate remakes. When you go immediately with the right parameters and you achieve immediately the most stable and robust plate, you are done. You don't have to play around in the printing press. Everything is good from the beginning. Here, the information from a customer in Lebanon. He combined an XPS Crystal with a 17-year-old washer. Yeah. Talking about the robustness of the plate when perfectly UV cured, you see even that works, and at a tolerance of plus minus 0.01 millimeter relief variation. There are big savings in that, as he described. When it comes to ink and substrate waste, also it's important to print your jobs to make life easy for the printer. Here, what Robert explained is we have, for example, for the solids, we have microcell surface, but this also works in the midtones. What does microcell surface screening means? It breaks the tension of the ink and ensures that the whole amount of ink is released to the substrate. Dean Scapes from Brandpack, for example, gave us a very attractive figure about a long run. This is something we haven't heard before, because in Europe, especially, we don't have long runs. In this case, he was running a job, this plastic bag of Aldi, 850,000 linear meters at 370 meters per minute without having to clean the plates. Even during lunch shifts and so on, they did not do anything to the ink. Yeah, they just restarted. After 850,000 linear meters, actually the bag conversion forming conversion line blew up, so needed to be repaired. They did that, and then they continued until to 1.3 million linear meters with the same plate set. This can only be achieved if you transfer all the ink, if you have less stress on the plate to survive with one set of plates. That's really a money saver, a cost saver, and keeping the press up and running. Avoid duplication plates, addressing a bit this a similar topic. If you have to make a second set of plates because you're not sure whether you can survive with one set of plates, you might be have the need to exchange the plates. A lot of customers do a second set. This all can be eliminated if you can trust the plate and you know that with your plate you can go for the full run. Yeah, and you achieve the high level of consistency. Reduced ink consumption. Again, here, microcell screening means that you transfer all the ink, but it means also at the same time that you can go for less ink. That is important, because what is required is that you have a very perfect ink laydown, that you achieve your solid ink density, the desired, you go to ISO color. Yeah, but this means that you can live with less ink. Here's an example of a customer who could go for less ink, especially as Robert explained, when you go for white, instead of going 2 times for white, you you have to check whether you can go for just 1 time white. If you calculate that, how much savings are in that, by using the right screening, you will see that there is a lot to save. When it comes to the worldwide saving impact of ink, yeah, we did a calculation. If you say, if you have a 20% reduction in ink volume worldwide, that is in total 2,500 trucks. Yeah, 86 kilotons of annual ink savings. Doesn't sound big if you take just one printing plant, but when you take the complete amount, that is sustainability. That is really saving. And last but not least, match ISO standards. So this is the enabler for fixed inkjet printing. Just to recap here, if you want to match a specific ISO color, you need to have a low delta E, and you will have a connected solid ink density. You want to match exactly this point. How can you achieve that? This is simply because of our screening. The microcell screening allows you to define exactly how much ink will be in the end transferred. If you put too much ink onto the plate, then the ISO color is lost. When you think about multiple colors, here you see if you are wrong in one color, you are a bit wrong in the second color and the third color and so on. You will never be able to simulate anything. Is it possible to simulate all colors? No, it is not. We know that. But to be tested, the number of customers who go for fixed inkjet printing is increasing. So for outstanding print results, it's always the combination. It is the complete front end, error-free. It is the ablation of the plate accurately, so that we transfer what we desired with the right screening, what we planned with the right screening. We build it up in the plate via the XPS Crystal, and then in the end, the print results were the brand owners and your customers, and you are happy. That's my part here. I will continue with automation, but now I give space for Piero of DuPont.
Yeah, hello, good morning also from my side. Let me start sharing my screen. Okay. Good. As already in the introduction mentioned, I will present our Lightning LFH plate made for the UV LED exposure, such as that. Just one technical info from the beginning. You will see during the presentation some QR codes for the further documentation and information. So if you want to take these documents, you can just take your mobile and scan this, and then you are able to download the files. So if you want, keep your mobile next to you. The customer trends we clearly see in the market is that more and more customers are investing in LED exposure, like the XPS, which is predominant in the market. These kind of exposure is widely accepted. The features of the UV LED exposure, I think it's a lot of them we heard already during the last presentation from Jan. with standardization and consistency, we have less user interfaces and operator errors, especially when you combine this with an automation option with these devices. We have a good day-to-day repeatability and the latest quality improving screenings technology, which plays in LED exposure. But why another plate? So as we heard from Jan, I think now it's even more plates in the certified plate from Esko than the 150, and a lot of DuPont Cyrel plates. But why there's a need for an additional plate? The answer is clear, because it's an LED is an exposure. The LED exposure is different than we know from the past. The LED systems deliver energy different to the plate. The output of the UVA intensity is 15 to 20 times higher. We have different UV spectrum, which is emits a bit more narrow, and the exposure is typically in a scanning mode. So that's our three factors, which is totally different for the polymerization, and that's the reason why we need the polymer, which is made for such kind of exposure. We have documented even more details in a white paper for this for some more technical background. So this is the first opportunity to download the white paper here. If you want, you can scan this and read through the document and have all the information between the differences on a tube and an LED exposure. And we are telling also in this white paper that an optimized polymer is required to get the best balance between the access time and the plate print quality. That's always a challenge when we certify our existing plates for the XPS. So keeping a good access time while you get the best quality. LED optimized plates make sense. So that's proved by our LSH, our first Lightning plate for solvent workflow. We have the award-winning in 2021 with this nice colorful job you see here. And now we have in 2023 introduced the LFH during the FDA in US. So it's presented. And also here we have already some nice samples. But first, let's have a look on fast and LED simplification of the workflow. As a lot of you know, this is a regular or standard workflow. So you see, we start with the back exposure on the left side, then handling the plate, so moving it from the exposure unit to the imager, image the plate, and then back to the same exposure unit for the main exposure. Right after the main exposure, we take the plate again and bring it to the processor, the solvent processor here. From the solvent processor, we need to dry the plate, and the last step, the finishing. So in total, we have six workflow steps and 5 interactions, which is shown here with these markers. So we have 5 interaction or 5 moving steps of the plate. When we combine the fast system with the Esko Crystal CDI and XPS unit, we have just only 4 steps and much less interaction. So we start with the imaging, as Jan already showed. So we put the plate on the CDI, and in case you have the automation version, you just put it on and start it. Will automatically mount the plate on the drum, image, demount the plate, moving to the XPS unit on the right side here, and start the exposure. So we have just one interaction. Take the plate to the processing unit, the thermal process here, fast unit, and then at the last point, we need to finish the plate in the light finishing unit. So even less interaction steps and we are also saving sometimes. But this I will show you later on a slide. The plate features and benefits. With the experience and science of the award-winning Cyrel Lightning LSH plate, we have expanded the Lightning platform into thermal plate making. So we have not only the LSH in these two gauges, 4567, so we have also another plate, the LFH, in the same gauges available. This plate is an ideal solution for any plate maker and converters for high quality and reproducible printing plates. And we are also enabled to use latest screening technologies such as Crystal. The LFH comes in two gauges, as I mentioned, 45 and 67 gauges, and the plate is designed and supported for LED exposure only. On the right side, you see the exposure times on XPS. We have two gauges. In 45, we have 5080, 42x60, and 4835. The times 22, 18, and 12, and similar to 67 gauge. Compared to our existing plates like the DFR, we increased the exposure, or we decreased the exposure time, so we have more productivity, 38% faster than previous thermal plates, and also to compare to competitor plates, we are quicker on this. And with this time, we are not creating any bottleneck in this workflow. XPS and fast, it's a simplified plate making. We have proven technologies, so DuPont is working with the thermal processors over 20 years now. We have plate making parameters on XPS with certified plates, and the same we do on our fast unit. We have defined and proven parameters which are working perfectly with our plates. And to reduce the environmental and physical footprint, this is a good solution. As we learned from Jan, we have less energy consumption, and the same will happen also on the fast unit. I show you in the next few slides. But first, I will show you the overview of the two systems. We have the solvent workflow on the left-hand side. You see the timings of imaging, exposure, processing, drying, and finishing. In total, we came out in the range of 3 to 4 hours. And when we compare this with the thermal workflow, we have, of course, same imaging times and exposure times. Processing, depending on thicknesses, we are a bit quicker. But in total, I think the main part is really the drying, which is not required when we use a thermal workflow, the fast workflow. So we are in the time of 45 minutes to up to an hour for the first plate. And this is a lot of time saving compared to the solvent workflow. But not only time, this is one argument, but for sustainability reasons, we see here on the left side, the non-renewable energy consumption is reduced from solvent to the thermal workflow by 56%, and the global warming potential is reduced by 38%. Both you see from solvent to fast, from solvent to fast. Let's have a deeper look in the energy consumption, or electricity consumption. You see the big part here is really the dryer. The dryer and the solvent recycle. Solvent recycle is on top, and dryer is here. And already the solvent recycle here on top is already a higher energy, electricity consumption as the whole workflow we have. So we can save energy over 80% by using fast. And this includes not the LED exposure, which also helps us to reduce the electricity consumption. And another very high value is the VOC emissions. Thanks to the technology inside, we have nearly no VOC emissions with the fast thermal, and that is completely different to the solvent. So we are able to save a lot of the VOC, nearly 100%. In total, we have here a summary. So we have the from the first chart, the 56 lower renewable energy and 38 for the global warming, 81% lower electricity consumption, and a very high value of nearly 100% of VOC emissions. If you want to learn more about this life cycle assessment, you can download here with these QR codes. So take the mobile, take a picture or scan it directly, and you can read a bit more about this and also how we did these measurements. So now we come to crystal screening. So what you see here for land file. And when we transfer this to the plate and the print, we do this here in the next pictures. So the crystal screening fits perfectly with our new plate, or vice versa, with our new plate fits perfectly to the crystal screening, the LED screening, and with the LFH we are able to hold such fine elements from the solid, which we know already from the past, to have a great ink transfer, high density, and a very, without pinholing, nice ink laydown. This is also part in the halftones, so we are able to get very good halftones in combination with crystal, and of course, perfect highlights. Here's another picture of the performance of, for example, here, crystal C19 combined with a solid pattern MCWSI. You see nice fade outs and transitions here, and smooth vignettes, and the overall tonal range from a nice solid, also in the midtones, no donut printing, and ending up in fine highlights. Of course, that could be better achieved with some HD screening. This is just for example. We have already some nice print samples done with the LFH promo prints in Poland and Brazil. You see this here on the right side. Hopefully you get some of these samples to see how good they are. The LFH is enabled to use the innovative screening technologies with high resolution, fine highlights, and high solid ink densities on our chipboard. Here we have a custom feedback. The new technology of LFH allows to use us to print with the highest quality in every part of the job, especially in low tones. So in principle, everything I have mentioned previously is here covered, also from a customer who's telling us it's very satisfied. And this feedback comes already during our field evaluation when we had the first product or the first plates developed in LFH. So we need to do some field evaluations, and this is our response from our customer in Poland. Yeah, now we come already to the last slide. So do you believe that lightning never strikes twice? So well, it actually does. You can also here scan the QR codes to come to the lightning page, and yeah, getting some more information if you want. And yeah, that's pretty much all from my side. So we have now completed our lightning family with another plate, the LFH. So we have now two LSH solvent and LFH for the fast thermal plate making, and I think it will be the last one. So yeah, thanks for your attention, and I will hand over again to Jan.
Okay, thank you, Piero. And talking about just a few slides about automation, where are we there with that? Simply the fact that we offer a CDI, the XPS, that was the intention to combine those to ensure that the operators just puts a plate and the robot does the rest of it, to free up the operator as much as possible. When you look at what is today the today's typical workflow is you need file preparation, you need bag exposure, main exposure. So there are a lot of steps which need to be tackled by an operator. When you do the complete front end, you merge the files automatically, as Robert showed via the when talking about the Flexo engine, or that can be eliminated. This means also elimination of errors. So it makes total sense to automate every step, the digital part, but also the manual part. When it comes to the manual part, we have today this combination, CDI and XPS Crystal, but there is more to go for. Yeah. There's just one video which shows where we are today, because our learning is together with you, our customers, is that the time of the operator is always pretty short. Expertise is required. And here you see how two plates are pre-positioned on the XPS Crystal. You just enter according to the job queue. You press the button and kick that off. This means the operator only needs to be there once in a while to put a new plate. Yeah, today he has to stand in front of the CDI and now need to put another plate. But you see that this plate is moved over to the XPS Crystal, will be then exposed, and the robot takes care of moving the next plate into the system. And now, during the imaging time of the CDI, anytime the operator can put a new plate, position it, as I did here, and just presses the button so that the next job then will be moved into the CDI and imaged. So it's a very quick workflow, frees up the operator time. Learning from the customers is it frees up to 75% of the time. Moving over now to the next slide, the last slide actually. Here you see what it means if it's automated and connected. So front end, file preparation, and so on. Here the plate feeder you saw here. You put a plate anytime the operator is available, and then it can be piped through. Even a processor can be connected, even a Kongsberg table can be connected. We have installations with a connected Kongsberg table, but we also have several sites where the complete line, plate feeder, CDI, XPS, and the processor are connected. That's the trend we see in the market. And we will see, I'm sure, a lot more in the future. From my side, thank you very much for your attention. And now let's move over to the question and answers part. I just saw maybe one question I can answer immediately. I quickly read that there was a question whether dust is a pain point on the open XPS Crystal. Actually, it is not. We have more than 450 XPS crystals out there in the market, which are excessively used because of the consistent quality which is output. Dust never was a problem. On the other hand, this open system allows quick access. The fact that we have a UV head and this kaleidoscope illumination system, which brings the plate from all sides, the UV light from all sides into the plate, also means dust is not a problem at all. At the same time, also the open system, which allows quick access, means also that you can have a small footprint. Yeah. So, and this all has been tested even in, let's say, challenging environments throughout the world. Usually the plate making department should be kind of clean, but we also faced situations which are not really as we would like to have it. So not really matching the ambient conditions, but even in these conditions, no problem at all. But more questions.
All right. So what we could do is I'm going to read the questions and maybe one of you can actually try to answer it. Okay. All right. So I just saw that you have already replied, Robert. So regarding the stochastic raster, so they're currently testing DuPont plates made with crystal screen, and they noticed that the transition to stochastic raster sometimes is a bit unexpected since it's automatically decided when ripping. So can you please explain quality difference between the built-in flat top plate exposed with bank exposure? And when we received plates with crystal, it was a bit unexpected since all went to stochastic. So do you have any recommendation on that? Like when to use the stochastic and when to use the regular one? The predefined screens.
Yeah, sure. Yeah, sure. I've lost my screen, but hopefully you can still hear me. So the stochastic element is based on a couple of parameters. Can you hear me okay?
Yes, we can hear you.
Yeah.
Oh, sorry, my apologies. So yeah, it's based on a couple of parameters. It's based on the dot size and the dot distance. And part of the print control wizard setup is to calibrate that. So if you haven't calibrated the dot size and dot distance, then you will certainly have some potential unexpected areas where you see the stochastic, and maybe even the stochastic could be too small, and then the dot starts to print dirty. So this is all part of the calibration process, and if anybody's interested in that theory or learning more, then we can certainly pick that up later.
Okay, so there's the next question. Can you please explain the quality difference between built-in flat top plate exposed with bank exposure, round dot plate exposed with XPS, and built-in flat top plate exposed with XPS?
That's a big question. Pira, do you want to pick that one up as a plate topic?
Well, so in principle, it's a very good question, because I had also some customers, they asked me, okay, when I have a flat top plate, why do I need a flat top exposure? Yeah. So in principle, that's true. Why do we need this? To hold such kind of solid pattern like MCWSI, it's not required. So you hold with both systems. But for example, to combine the latest screening, like the crystal ones, we need the XPS to apply this. And another point is the consistency of the XPS. That would be more your part. But anyhow, the consistency of the XPS is still one of the benefits. So all the points that Jan mentioned, you have the main and back exposure at the same time. The repeatability, automation option, and the very even output for a good relief. Yeah, all these benefits comes with the XPS, and yes, one point, the one-to-one or the flat top technology as itself, it's not required for that, but for all the other parts, it's still valid reasons. Yeah.
Okay. Next one is microcell good for UV ink?
So it depends on the substrate that you're looking to print on. So you have a choice of surface patterns. Typically, what we would see is a groovy pattern works a little bit better with UV inks on film substrates. That's a generalization. Another generalization is that if printing on paper-based substrates, you typically would not need any surface patterns. But yeah, it's just down to the difference in the rheology of the ink between solvent-based inks and UV inks, which means that different patterns work best with those different combinations. Hope that makes sense.
All right. So we are slightly actually over time. What we could do is we can actually try to respond these questions in writing later. You already have contact details of the team here, so feel free to drop us a note. Okay. Right. Again, so thanks for a very informative session, and thanks to all the participants who joined today. Thank you.
Thank you very much. Bye-bye.
Thank you.
Have a great day.